It's time to assemble the CNC machine. This video will focus on SX linear rails assembly. Hi, welcome to Slow Engineering. I'm David. Let's start from the base, the y-axis. I designed the base as sturdy as possible. The center line is the y-axis motion mechanism. Two linear rails are placed on each side of the vertical 2060 aluminum extrusion. In the middle is a 2000 aluminum extrusions to cover the bottom and space a certain distance for the y-axis ball screw. Before assembly, taping M6 threads for the certain holes and using a knife edge square to make sure the cut surface is vertical to other planes. It is recommended to find a glass as a flat reference plane for alignment. Place down the 2000 extrusion in a horizontal orientation, and place two 2060 extrusions vertically at each side of the 2000 extrusion to make a C shape with open on the top. Next part is the ball screw supports. The ball screw supports have different designs on each end. One is the side with the motor, and the other side only supports ball screw bearing. The side with the motor has more mounting holes on it. The bigger holes for the motor mount faces outside to connect to the motor mounting plate. Fasten the M6 screws on each side to make 3 extrusions into a piece with 2 ball screw support parts. It is important to keep 2 support parts in parallel for the ball screw installations in the near future. Double check the surfaces are vertical to each other inside by using a knife edge square. There are 3 axes on the CNC router, so do the same methods to prepare all 3 axes. After all the bases of axis motions are prepared, it is time to install the linear rails on the top. The rails were ordered in pairs, so the first thing is to find the reference one. The manufacturer has already marked the reference rail with MA. This reference rail will become the reference line to align the second linear rail when installing. Install the T-nuts under the rail and place the reference rail on the extrusion. Use 3D printed tools to closely align the rail with the extrusions underneath. Then slightly tighten the rails with screws for further detailed alignment. Here I use the lever dial gauge to measure the distance between the rail edge and the extrusion edge. This dial gauge can operate in both directions to show the positive and the negative ranges to the reference point. Place and fix the dial gauge with a holder on the top of the cartridge. Adjust the holder to make the dial gauge tips to touch the edge of the extrusion underneath. Then gently slide the cartridge to see the dial gauge value. If the value changes, it means the rail is not aligned to the extrusion. Make adjustments until the values of the dial gauge are the same at all positions. Next, tighten the screws with a torque wrench with a certain torque value provided by the rail manufacturer. After placing down the reference side, the other side will be similar. But this time, the datum is not the extrusion underneath. It changes into the reference rail. Place the dial gauge holder on one of the cartridges and point the tips to the reference rail this time. Slightly move the cartridge and check the rail alignment with the reference rail. Then tighten the screws to secure the second rails with a torque wrench with certain torque. Repeat the processes on the other 2 axes. Here is the linear rails assembly part. I have to say, the real assembly is not like a theory. even with a precise lever dial gauge to calibrate the linear rails. It takes time, and they are not easy to calibrate and adjust. Next part will be the ball screws assembly on these axes. Like, share this video and subscribe to this channel if you learned something. Or consider becoming a Patreon member to support my work. Thank you for watching, and see you next time.